Okay, cool. Good afternoon, everyone. Thanks for coming to this session. I hope you've all had an excellent PowerShell conference. We're big fans of Windows at Amazon Web Services. In fact, just this week we celebrated 10 years of Microsoft Windows and SQL Server running on AWS. So it's a long history there. So my name's John Austin. I'm Solutions Architect with AWS based here in Singapore. So I work directly with customers and we talk to them a lot about what their needs are in terms of the Microsoft stack. And my colleague here, Nana, is all the way from Seattle to talk to you about a really cool product that we have in the AWS platform called AWS Systems Manager. So that's going to be the crux of the talk today. So just to briefly outline the agenda, Nana is going to be running a whole bunch of demos for you, right? So it's not going to be a slideware presentation. We can skip the overview of PowerShell. I think that's safe to say that everyone here is something of an SME. Certainly it's been a few years since I wrote any PS1 scripts, but we'll get there eventually. So we're going to do a quick overview of Systems Manager and then I'm going to pass it to carry out the demos. Okay. So I mentioned that we talk to our customers a lot, and this is really how we drive our product roadmaps, how we prioritize features. It's 99% driven by the customer. So we don't kind of have a bunch of engineers sitting in a back room dreaming up new things. We go out there, we talk to them, our customers, and we find out where their pain is, and then we build products and services and features against those kind of pain points. So the idea that this traditional tool set that we've used for many years in on-premise environments doesn't neatly scale to the needs of cloud. Enterprise-wide visibility is something that I think a lot of enterprise IT groups struggle with. Maintaining CMDBs, being able to pull information in an accurate and timely manner. The nice thing with cloud is that that's kind of taken care of for you. So the fact that you can interrogate an API and get a real-time, up-to-the-minute JSON description of what your actual infrastructure looks like. We don't want to come to deploy multiple tool sets either. We don't want to get into this kind of management hell of having multiple platforms for managing different tasks and lots of overlap and cost and everything else. So being able to operate safely at scale is really important because cloud is elastic and you may be having 100 servers today and 1,000 tomorrow and 10 to the day after that. Our tooling and our management capabilities need to reflect the elasticity of cloud. So that's really important. Let's go back one. Yep. Is it skipping ahead? Sorry. Yep. Yep. Yeah, that one. Licensing is also a complexity that we see a lot of customers struggling with, is being able to maintain that, remaining compliant with the contracts that they have and honoring those terms that they've signed. And then, skip ahead, yep. So how do we kind of tackle this idea of operating at scale and hitting those security challenges head on? Being able to have a really reliable source of information about what's going on in our environment. So these are the kind of the primary constructs from Systems Manager, being able to group your resources together as it makes sense, visualizing and then acting on the data that you are able to pull out of the platform. So Systems Manager is great in the sense that it's not a cloud-only service. You can actually extend it back to your on-prem management. Because the agent can be installed anywhere and the management plane sits within AWS. So a really powerful feature for customers who might be operating in a hybrid mode where they have some applications remaining on-prem, but they're building out new capabilities on cloud. Open source, so the actual agent for SSM is open source, so your security teams can go through it with a fine-tooth comb. Written in Go? Yep, Go, that's right. Cross-platform, Windows, Linux, and the nice thing is it's also extensible, right? So this product is a set of tools and capabilities, but very extensible through technologies like PowerShell. So these are the 9 primary capability areas for Systems Manager. We won't go through them all in detail. Nana is going to actually cover 6 of these, I think. But things like being able to do an inventory of our environment, being able to run an interrogation of where we are in terms of patching at an operating system level. Something that's traditionally hard to get 100% coverage on. Run command, which is awesome, which means we can now start to operate in a headless mode. So we don't have administrators RDPing into Windows servers, SSHing into Linux servers. We can use the tool Systems Manager to actually push ahead without having to log in, and it kind of reduces the attack surface and it reduces the possibility of a human error. So I think at this point we're going to jump into a demo, right?
Thanks, John. So now we are going to jump into a lot of demos, because that's what PowerShell conference is all about, right? We want to look at a lot of PowerShell code. So look at here is all those capabilities in Systems Manager that fix with PowerShell. Remember what the slide that Jeffrey put this morning? You want to lift and shift. There's a lot of capabilities, a lot of artifacts that you have built around PowerShell. And then how do we take all of those and start using them with Systems Manager so we can actually scale to the cloud? And one thing to call out again is Systems Manager can manage so everything that I'm showing here except one feature is available to do on-prem for your hybrid environment. So let's first start with sessions. I have a slide explaining what each of them is, but I will quickly go over before we actually jump into the demo. So Session Manager provides centralized access to resources. It's basically like you open a browser and you get a console. There's no SSH or anything to manage, no inbound ports to manage. You don't even have to enter a password, right? You just open Sessions Manager to a Windows system and you can start typing. And you can also set your preference to say log, audit everything that the user does on the console, and they can either go to a storage bucket or next we obviously have no, it connects to your instance. So I'll show what that means. Re-log in, I was logged out. Okay. So if we go to services in the AWS console, before we start, for the benefit of everyone, Systems Manager is offered at no additional price. So if you have an AWS account, you could just go and start playing with Systems Manager. So you go into set of services, and under management tools, you would find Systems Manager in here. So you select that. And you find all of the capabilities of Systems Manager in here. And the first one I'm going to start with is Sessions Manager. So I want to start a session. So here are the systems that I've already pre-configured in my environment. So as I said, this is the only feature I'm going to talk about today that only works for EC2 instances. Everything else will work for both on-prem and in the cloud. However, this is going to be one of the easiest and most powerful ways in which somebody can interact with PowerShell. Makes Windows management much simpler in AWS. So I select an instance, and I say Start Session. And there you go. You get the PowerShell prompt. You can start typing. The usual command, get process. You even get tab completion. And everything you type in here can be audited into a central configuration location. So I can go in here and say preference, and I say CloudWatch log stream enabled. So what that means is the whole PowerShell transcript is logged into CloudWatch for people to search and audit. So as you can see here, there is no need to maintain like any SSH keys, no inbound ports are open, and you don't even have to enter the administrator account. If the system is available in AWS account, it's centrally managed using AWS access control, and just come in and start typing in. That's the easiest and most secure way to get into PowerShell and manage things on Windows in AWS. Next, let's look at run command. So run command is the capability through which you can run a command remotely across a fleet, right? You can run it against EC2 or on-prem. You can run both like shell script, PowerShell script, Ansible, whatever that you would want. The nice thing is the agent, again, does not require a port to be open. The agent will poll, get the message, run the command, and send the result to the central systems manager console. So let's look at a simple example of run command. So one thing to keep in mind is systems manager. So before that, let me walk through how I add an on-prem instance. So you create an activation. So you basically give it a name, say demo, and it essentially creates a role. So all this activation does is it gives you an activation code and an activation ID. So you save this and pass that activation when the agent, and the agent automatically registers your on-prem instance, and it will show up as a managed instance. So the instances that start with an MI are basically on-prem instance. So I've already pre-configured one in my environment, and we can now manage it like any other instance that runs in AWS. So now what is run command? So run command, as I said, is a way by which we can actually run commands remotely across all of AWS. And run command, so there is the concept of a document that's defined in Systems Manager. It's pretty simple, right? We have scripts in PowerShell. Similarly, other configuration tools like Chef or Ansible have their own artifacts. An easy way to explain is think of document as one more layer of abstraction that will take any artifact and make it as a standard Amazon resource. So then there is a none. So it's like any other resource, like VM is a resource, for example. Storage is a resource. So a document is available in AWS. That means it can be version controlled, it can be shared with other accounts, and you can control like who can invoke it, etc. So a simple way to execute PowerShell command would be, so go in here, I say run command, I choose the document that's already there, run PowerShell script. So basically all this document does is, if you look into it, it essentially, every document has a syntax. It can be written in JSON or YAML. There are a bunch of parameters, and there are like a bunch of actions that you could do. So one of the actions is run a PowerShell script. And in this case, the standard document, all it does is it takes the script as a parameter and just executes it. So if you go in here and I say run PowerShell script, and I can type whatever script I want. So let me say restart service, Windows update, dash verbose. And then I can say, I can either specify a tag or manually select the list of instances where I want to run. So I select a bunch of instances, and I just hit run. So now you find that this command is running against 2 of these instances, and if those instances are intermittently not available, the system would wait, and when they come back online, the command is executed, and all of the results are consolidated here. So now they are done, and you could go in, and you could see the command just ran. Right? Simple way. There is a pre-configured document. Anything AWS does, so you there, type in your PowerShell script and just run it. So you can run it against a whole fleet. And if the output is more than 2500 characters, it's returned to an S3 bucket where you can go and look at the output. So that's a simple way in which you run a command. So now, you can also author documents where you can embed the PowerShell script that you would want to run. So think of like writing a script and you put it up in the PowerShell gallery that people consume. So how would you like write a script that other administrators or operators within your share it? Essentially, here is a simple DSL, right? There is a parameter to the script, and here is the actual script. So I'm getting in a service name. I'm saying the action is I want to run a PowerShell script, and here is my actual script contents. So this is like in YAML, and you can have a full script written in here. So now I can go ahead and say, run a command. I just picked the document that I just authored, restart service command. You provide a parameter, select a bunch of instances, and you just run it. So essentially, you took a PowerShell script that you already have and converted that into an artifact that can be used within Systems Manager. And this is a fundamental building block that we will see how we can actually build more layers of compliance and more layers of security on top of this. So this is a fundamental building block just to internalize. So again, the command just ran against 2 machines. And one of the other things, like I'm not going to go into details, is there is built-in rate control that is available. So you can say, here are the number of systems that I would want to run with, and the error threshold when you want to bail out, etc., etc. But essentially, here is a PowerShell script that's converted into a document that you just run against your fleet. So next is parameter store. So now we have a PowerShell script, and of course, one of the recommendations is you want to separate your configuration from code. So parameter store is the feature that's available in System Manager that lets you store all your configurations. You can store regular configurations as well as secrets. So that's the advantage. Like time and again, when you want to store credentials and passwords and you want to pass it on to a Windows or a Linux machine, right? It's been like very difficult. And one of the advantages, in fact, this is one of our very popular features used within Systems Manager. You can centrally store all your secrets and pull them down from the PowerShell script and then run them within a node. And of course, this provides hierarchy and version control. You can audit and control access, like who can get access to which parameter. So that way, it is a central parameter store, like central store for all the configurations, and you can choose which user has access to what. So thereby you can segregate who has access to the different secrets that's available in the environment. And there are like change notifications that's possible. For instance, if a secret gets like rotated, then you can trigger an action to go and rotate it in all the instances that's possible. So that's what parameter store offers here. So in parameter store, what do we do? So here I have like 2 parameters already created in the store. One is my DB string, it's just a connection, and you have like a secure string. And this secure string, you can either have the default KMS key that is used to encrypt the secret, or you can bring in your own key and that's encrypted. So like, not even SSM has access to it. It's encrypted with your own key and it's decrypted whenever it's pulled in. So I have this pre-created, and now I can write a PowerShell script this way, right? There is a PowerShell command, let get SSM parameter. It just returns you whatever the parameter that you want. You get the value, and then you can say, with decryption, if it is a credential, it decrypts, and then you convert that into a secure string, and now you get a credential object. So this is one of the popular mechanisms that's being used, because centrally people can store their secrets, and you can pull that out from like a PowerShell script or any other script, but here we will focus on the PowerShell aspect of it, right? So all of the configuration that needs to be separated, including secrets, are now like separated out. And here is a sample script that you would just execute. So if I were to just go in and run this command, let's say against a single instance, something like this. So we get a credential object constructed, and then that can be used within the script. Next, manager. Oops. Okay, looks like there is a copy paste error. So let me walk you through what state manager does. So state manager, think of state manager as a service that helps create associations. So what exactly is an association? Association is a way by which, you can periodically start to enforce a policy. For example, you can say, hey, whenever an instance with a specified tag comes up, you want to run a configuration. Let's say you want to configure it as a web server. So you can either run a PowerShell DSC configuration to configure it like a web server, or you may be able to run a chef config or Ansible, whatever it is, right? So one is you can do things when an instance comes up. It can also be used to periodically enforce policies. Like let's say you want to enforce a security policy like once every 30 minutes, similar to what say group policy does. Or you want to enforce other best practices like say once a day. Or you want to enforce that a backup policy kicks in like once a week. You create different associations and then you say what is the target document that it runs, and the target document can be a PowerShell script. For example, let me do this. So I say create an association and I can give it a name. So I say I want to configure my services, and you choose a document. So I'm going to choose one of the documents I authored, which I say is like configure services. Run the default version. So let's take a quick look at what this document is, right? So essentially what this does is it has a DSC configuration here that basically disables some of the services, installs IAS, etc., right? Some configuration of services. And then at the end of it, it applies that configuration. So this is the script that I have that's created as a systems manager document. And now I go ahead and create an association. I say run this document whenever, let's say, an environment, any instance with this tag is available. So for all the existing instances that's tagged this way, this configuration will be run. And whenever a new instance is created, either it's an on-prem instance that's managed via an activation, you tag it, or an EC2 instance with the same tag comes in, this configuration gets applied. And how often? You could say whether it's on a schedule or no schedule. Like, I can say just run it the first time, and you create this association. And then you could see this association now has an execution history, right, if it's periodic. So here is the association running. And you would find like, okay, here are the instances that are tagged as environment is production, and it's going to go ahead and configure those. So these would eventually run to completion, and what will happen is the services in those instances would be configured. Now, you can actually go ahead and create different associations at different intervals. Like for example, I can say I want to collect the complaints, like DSC complaints, say once every 30 minutes. So you can say, okay, you pick the document that you want to execute, which again can be a wrapper on PowerShell. So I say I want to collect the complaints inventory. This is the version I want to run, and here are the tags. And you can specify, okay, what is the frequency with which you want to run? So I can say, okay, I want to run this every 30 minutes. And you can create this association. So what happens is now the compliance information, DSC compliance information gets collected once every 30 minutes. So this is a mechanism through which you can enforce compliance best practices. Things like security best practices and other backups, things that you want to do periodically. You can create different associations targeting different tags, and this just applies throughout your environment. Anytime a system with a new tag comes in, this association is automatically applied. So that way, people can separate their environments based on tags, and the policies are automatically applied as and when a system comes in that satisfies the tag criteria. Had a question? it's inside the instance.
It's inside each instance.
Correct.
So the agent pulls down the document, hands it off to a handler.
And the handler runs it inside the instance. So let's say I create this. Okay, so now I have like two associations running. So this is the one that we ran the last time. Here is the execution history. So it ran on all of these instances, and you can actually go and check the output. So it just applied the DSC config, the first one that we just created. So next is inventory. Systems Manager has the notion of inventory where it collects a default set of inventory from every instance. So there is an agent, as I said, that resides inside the instance, and it collects default information. For example, on Windows, it collects information around applications, what AWS agents are installed, what services are running in what state, and there are like few other things that you can collect. It supports both EC2 and on-prem, so long as it's a managed instance that's in there. The most important thing here is it has the ability to collect custom inventory. So for example, people want to collect information around license, right? That is something that's not standard, and there's a specific product about which you want to collect license information. You can tag that as custom inventory, and you can actually send it centrally to Systems Manager, and then you can query on it to see, okay, how does your environment look like? For example, that can also be used to collect like the status of DSC configuration, and you want to you can centrally store that. So the other example that I just created, State Manager Association. So what this does is, if you look at this document, so essentially there is an API that says write SSM inventory, and there is a specific format in which you actually have to run it. It's a JSON structure, nothing fancy there, right? So essentially here is an object of type inventory item. There is a schema type name. The type name has to be custom : whatever type name you want to provide, and then there is a dictionary of like whatever properties that you would want to collect inventory on. So in this case, what I'm doing is I'm just taking the get DSC configuration status and taking all the properties that show up by default, and I'm just submitting that as a custom inventory from every instance. So what does this give me is, when we get to the inventory section, and I can go in to, let's say, any instance. So you get to see here the DSC compliance information that's submitted as an inventory. So any information that you would want to collect just via a PowerShell script that's running within the instance, you can collect any information, and that gets centrally logged in as a custom inventory type. Now you would be able to run inventory queries on this. Like Systems Manager inventory, you can export, you can create what's called as a resource data sync, which is you take all that information and then you can submit that into an S3 bucket, and now you can start building like Athena queries on top of it, like rich structured queries, and people use it all the time to find what is the status of information. So you can use this to find like complaint status, you can use this to find like licensing information, any custom information that you would want to do, and it scales across the fleet because it's all centrally consolidated via Systems Manager inventory. And again,
So you can extend the inventory with PowerShell agents. Can you extend it with any document, like any of the other languages?
you can do it with any document, yes.
And then the base stuff, how do you get that? Is that PowerShell, or do you have a native agent that gets it?
So the native agent, the agent collects some of the base information, and then extensions are supported either shell script or PowerShell.
The base agent is what, native code, or?
Go. The base agent is written in Go. Go is a choice because it's cross-plat. So I'm not very sure on the details. Yeah. So next is automation. So automation is systems manager's orchestration and workflow engine, right? It helps standardize best practices, and it also lets manage non-instance based resources, like if you want to manage DynamoDB or storage or networking or other things that are not running within an instance, then automation is the choice. It also lets run in interactive mode, meaning like if you want to like run a run book and say you want to go one step at a time in terms of troubleshooting something in an environment, you would use automation. It does provide at scale operation. It again provides like rate control. There is conditional branching, so meaning you can say, okay, if it is Windows, run this particular PowerShell document. If it is Linux, run the shell script document and things like that. But the most important thing that it helps is in terms of delegated administration, right? So let's look at what automation does first very simply. So let me pull up a simple automation document here. Again, automation has a series of steps defined by own DSL, and it also has, it's a different document type. So here is restart Windows update with approval, right? A simple automation that I put together just for demo. So it has a set of parameters. So first is it's going to request an approval saying, hey, I want to restart, can I go ahead? And the required number of approvals are available, it will then proceed with the action. Then it's actually running a command document which basically has a PowerShell script to restart Windows update. And then finally it's like, it's a workflow. So, let's say you want to send out an email saying, yep, so-and-so restarted on this particular system. A simple IT workflow that somebody would want to execute. So now let's say I want to execute this. Okay, I want to pick an instance. So I want to pick something. Here is the approver, and I say execute. So you see that there are like 3 different steps in this workflow. So this is in the waiting state, expecting the approver to approve. So let me go ahead and log in as the approver. So this is waiting. I say approve or deny. I say approve, submit, and once this approval is done, you'd find that this execution proceeds. It executes the document and basically sends out an email. So you could see like, it sends out an email here saying, hey, Windows update service was restarted, right? It's used in typical runbooks when somebody touches something in a production environment, send an email notifying that, hey, so-and-so did something on your prod environment. So this is how automation helps run IT workflows. Now, how do we use automation to actually build delegated administration scenarios? So whoever is responsible for certain tasks, we build higher level abstractions. So what I'm going to do is the scripts that we have built with PowerShell so far, and then wrap it around automation so people can do selective tasks based on what their responsibility is. So before that, a security model for automation. So automation can run in 2 ways. One is the way I just executed, which is in the context of the incoming user. So it can run things in the context of the user. For example, as a user, if I have permissions to restart a machine, then it will just be able to do that. And if I don't have access, that operation is going to fail. That workflow is going to fail because it's running in the context of the incoming user. There is also something called as a notion of role in AWS, where you can have certain permissions associated with the role, and you can say the automation has to assume that role and actually do the tasks. So that's more like elevation of privilege. I, as the incoming user, may not have access to a particular resource, like for example, to restart an instance or do something with it. However, the role embedded within the document can actually have privileges, and it can elevate and do things on my behalf. So this, real quick, if we pull up any automation document, there is an option to specify here assume role. Here it's coming out as a parameter. If we don't specify, then it's in the incoming context of the user, but it's possible that you can embed a role with specific privileges and do elevation of privilege. That's the construct there. So what does delegated administration do? It basically uses embedded assume role, meaning like you embed the role within the document, and then you let a user only invoke certain documents that you would want to proceed with. The users need not directly have permissions on the resource. For instance, I do not have direct permission to restart a machine. However, the role embedded in the document does, and I have permissions to invoke it. So here are the 4 personas, right? The author, who creates the documents and therefore embeds the role. The administrator, who publishes the documents within the account. The operator, who basically executes it. And then, of course, there can be an approver who can approve or deny the operation that needs to happen. So here is an example scenario, right? We want John, the operator, in charge of EC2 instances to restart any service within instances that are there in the department, right? That's the only task that we want John to be able to do, and we don't want them to give direct administrative privileges on any of the instances. So how do we go about doing that? So first is, author the document, specify the assume role, and then ensure that the assume role has necessary permissions, and then specify the required permissions for the user. Let me quickly walk you through how that happens. So here is the document I have. Here is the service role that I have embedded. So what this does is this role has permissions to go ahead and execute a command within a document. I am basically using the run command document we authored before, which essentially has a PowerShell script that does a specific task. In this case, the task is restart a Windows service. So the step 1 we did is author a run command document. So here is restart service. Here is a document that we authored, and this just has, sorry, not this one. Restart service command document. So this basically has the PowerShell script that does the task. And then this command document is now embedded in an automation document that has the specific permissions here, and it's just going to invoke this command. And now what we're going to do is I'm going to go to the resource permissions. So I'm creating a user. So I have a user which is just the operator, and I'm stating that all this operator can do is basically run this particular document. Like, these are actions that are just there for the UX, so I can show it here. But essentially, this user does not have access to running any command or administrative privileges on the instance. All this user is allowed to do is start automation execution on this particular document, and that's about it. So now, if I log in as the particular user, so let's do that. So I'm logging in as the operator. In the interest of time, I'm not actually showing that regular operations would fail, but trust me. So I can go in here and I say execute the automation. I choose the restart service document and I say version 1. And let me pick up an EC2 instance. Oops, service name. And you would like, it will actually go ahead and perform the task. So a simple PowerShell operation that you to a user and make sure that they only execute it in a specified sequence. You then put it into an automation document with an embedded assume role and let the user operate on only those documents. Now you can add additional steps like sending email or approvals, etc. Part of it, so there is a fully authored IT workflow, and people always follow the standard, procedure or standard manual of they are dealing with something that's pretty important. So in summary, essentially Systems Manager helps leverage all of the PowerShell artifacts that we would have, right? And it helps, together with Systems Manager and PowerShell, together they actually help scale to a very large number of instances. It helps separate code from configuration, and especially secrets, right? And it also helps like collect custom inventory, collect custom compliance information, etc. Essentially, there is a lot of leverage that Systems Manager can provide in terms of scale by reusing all of the PowerShell artifacts and PowerShell knowledge that we have developed so far. And it helps convert all of the PowerShell scripts that we have into operational IT workflows that we can use both within on-prem instances as well as in the cloud. So all of the demos that I just showed, if you want to play around with them, they will be publicly available in this GitHub link, Nana Lakshmanan /PSConf Asia 2018. And here are some useful links that if you would want, look at AWS Management Tool blog, overall AWS product page, and the AWS Systems Manager repo, where you can find the agent open source, as well as a lot of artifacts that we have from the community, like documents. You can like fork them and start developing if that helps get onboarded on the Systems Manager. So that gets us to the end of the presentation. Any questions that I can take?
In regards to Session Manager, is there a concept of fan out there? Like, rather than going into just one node to do something, is there a way to do command against multiple nodes?
So the way to do command against multiple nodes is run command. Sessions Manager is specifically meant for, so the question is like, do we have an option in Session Manager to actually fan out? So when you want to fan out and do something across multiple nodes, you would use run command. Sessions Manager is specifically meant for interactive usage without having to, open up ports or manage SSH or, admin credentials. That's the idea there. Yeah, it's a kind of operation. Yes. Okay, I just used the web browser here because it's easy to walk through as there are multiple concepts. Everything that I did here is doable using PowerShell, AWS PowerShell module. So you can do it from the command line or using the AWS CLI or through the web browser. So the question was, should everything have to be done through the browser? And the short answer is no. Cool. So if there's anything else, feel free to let me know on Twitter or send me an email if you had more questions. Thank you.